Okay, how are you? Let's consider these two given functions. F of x is equal to 1 over x plus 1, and we also have g of x, which is equal to x over x minus 2. These two functions are considered to be rational expressions because we have variables that can be found in either or both the numerators and denominators. Now we are going to add and subtract these given functions. In short, we are going to add or subtract equivalent rational expressions. Let's start with this notation, f plus g of x. When you have this expression, you simply try to add the two rational expressions here. In short, for f of x, you have 1 over x plus 1 to be added with your g of x, which is x over x minus 2. Take note that we have here rational expressions to be added. This works the same as adding of fractions. When we have two fractions, we cannot immediately add them. We can only add them if our two fractions are considered to be similar fractions. Similar in the case wherein the denominators are of the same expression. Here, we have two rational expressions, but the denominators here are not the same. In short, they are considered to be dissimilar rational expressions. To do that, we are going to look for the LCD. Just like 1/3 plus 1/2. We are going to solve for the LCD of 3 and 2 so that we could add the two fractions, considering the equivalent fractions that could be formed using the LCD. So the LCD of 1/3 and 1/2 is 6 because that's 3 times 2. Here, we also just need to multiply our denominators to get our LCD. You have x plus 1 times x minus 2. Now don't multiply it in the meantime because there might be a possibility of canceling one or both later depending on our numerator. But this is our LCD. Now we need to form our two rational expressions into equivalent rational expressions using this denominator. And we could do it like this. We will divide the entire LCD by each of the denominators. So let's start with the first. We divide this by x plus 1. So we cancel x plus 1. We're leaving x minus 2. Okay? That x minus 2 is now your multiplier to the numerator of your first rational expression. This works the same as, again, 1/3. I'm going to write it here. Let's say 1/3 plus 1/2. The LCD for that is 3 times 2, which is 6. And to add, we will divide 6 by 3, so we have 2. So you have 2 times 1, which is your numerator here. For your second, plus, because it's separate, is plus. 6 divided by 2 is 3 times 1. So similar thing will happen for rational expressions here. So we divided the entire denominator by this denominator here, leaving x minus 2. That's your multiplier to your 1 here. Now the operation is plus, so you will have plus here. We'll do the same thing on the other side. Divide this by x minus 2. By doing that, we are left with x plus 1. And that's your multiplier to your numerator here, which is equal to x. Because this is your original numerator. So after this, we simply multiply the numerator. Again, leave the denominator as it is in the meantime. And let's check later if there's something that we could do to cancel one or both. And if there's none, then we stick with the denominator as it is. So when you multiply this, you will have x minus 2, because that is x times 1 and negative times 1. And here on the other side, plus x times x, you will have x squared, and then plus x. This will give us a result of, we arrange it, x squared plus 2x plus, minus 2. All over, you will have here x plus 1 times x minus 2. Let's check if our numerator here can be factored with any factor that will ultimately lead to a cancellation here later. This is a quadratic trinomial, so let's factor that using AC way. So you have 1 times negative 2, you will have this expression here. So 1 times negative 2 is negative 2. And the factors of negative 2 are negative 1 and 2. You could also try positive 1 and negative 2. We only have 2 pairs of factors, but when we add both of this, none of this pair will result to the middle coefficient of positive 2. This means that our quadratic trinomial of our numerator is as it is. We can no longer factor it. That's the result for our f plus g of x. Now let's have the second notation, f minus g of x. Since we are dealing with the same expressions, so we will have here 1 over x plus 1 minus x over x minus 2. We will have the same LCD. It only differs here. The operation would be subtraction. So let me just copy the entire expression here. So again, we have the same denominators in LCD. So it won't change here. The only difference is this, minus, because we have minus here. You have your multiplier of x plus 1 times x all over the LCD, same LCD here, x plus 1 times x minus 2. Next here is to multiply the numerators. We will still have x minus 2. And take note of here, we have a subtraction symbol or a minus sign. So when you have x times x, that's x squared, you will have negative here, negative x squared. Next, you will have this expression here, x times 1 is x, then times negatives, you have minus x. All over, you have x plus 1 times x minus 2. Arranging all of this, you will have negative x squared, x minus x is 0, you have minus 2. All over, you have x plus 1 and then x minus 2. Notice here that we cannot factor our numerator, and because even if this is subtraction, you will have a perfect square here, and you could also treat 2 as a perfect square root of 2, but since we have a minus sign here and we don't have a square, perfect square which is negative in sign in the realm of real numbers, this is already our final answer. And by the way, you could also simplify this since we are sure that we can no longer factor our numerators here. So we simply multiply that to an expression which is equivalent to a quadratic trinomial. Nevertheless, here are the answers for the sum and difference of the two functions originally given as rational expressions. That's all for today. You're dismissed. And please do not forget to subscribe now.